Lesson 714, Equations with Fractions and Decimal Coefficients. Today's learning target is, by the end of the period, the students will solve equations with fraction and decimal coefficients. And I'll just remind you that a coefficient is the number in front of the variable. Okay, the in class, 7-39 to 7-44. The homework, 7-45 to 7-50. Okay. Okay, that looks good. All right. Okay. 714, equations with fraction and decimal coefficients. Are we there yet? The Sutton family took a trip to see the mountains in Rocky Mountain National Park. Linda and her brother Lee kept asking, "Are we there yet?" At one point, their mother answered, "No, but what I can tell you is that we've driven 100 miles and we are about 2/5 of the way there." Linda turned to Lee and asked, "How long is this trip anyways?" They each started thinking about whether they could determine the length of the trip from the information they were given. So Linda's thinking about a line diagram, and Lee is thinking about a big triangle and a little triangle, so he's probably thinking of some kind of scale factor, and this is multiplication. Okay. Explain how both Linda's work and Lee's work illustrate the situation described by their mother. What does x, the variable x, represent in each diagram? X represents the total distance. Okay, so the 100, see in Linda's, it's really easy to tell. The 100 represents the distance they've traveled so far. 100 represents the distance traveled so far. Okay, and then the 2/5 also represents the distance that was traveled so far, but it's written as a fraction. So 2/5 represents the portion or fraction of the trip traveled so far. Can you see that? Oh, no, I was off camera. I'm sorry I was off camera. I'll scoot that up. I'll read that again. Oh my goodness. Okay, so x represents the total distance. 100 represents the distance traveled so far. You can see that on Linda's. 2/5 represents the portion or the fraction of the trip traveled so far. Okay, so what equation could represent the situation? 2/5 of the trip, remember x is the whole trip, equals 100 miles. Use the scale factor as a multiplier. So the scale factor is the 2/5 from Lee's thing. And the x is the total distance in miles. Is the answer going to be more or less than 100 miles? Well, think about this. If they've only gone 100 miles, see, and they are not there yet, do they have more or less to travel? More. Explain your thinking. Explain your thinking. Okay, let's explain our thinking. They already traveled 100 miles and have more to go. Okay, Linda remarked to Lee, "When I look at my diagram, I see the total distance is 2.5 times the distance we've driven. Okay, so we agree with her, and I'll show you why. So if this is the distance they've driven, and that equals 1, and so for every 2 little spots, that equals the distance they've driven. So here's another 2, so that equals 1. We're going to add those together. And this is half of that distance, so that is half. So what's 1 plus 1 plus half? 2 and a half. How can you add labels to Linda's diagram to show 2.5 times the distance? Well, we just added the label, so we're going to say C diagram. And then take this and draw an arrow so we point at the diagram. Okay, so how long is the trip? Okay, so this is 100. How much is this? This is also 100. And what's half of 100? 50. So 100 plus 100 plus 50 is 250 miles. Show how you know. Okay, so how do you change 2.5 to a decimal? 2.5. 2.5 times 100 equals 250 miles. Let my pen hold that while I switch papers. Okay, let's go to the next page. These things that he knows about, what he knows about similar triangles can help. Okay, so we don't have 722 because that was not on this lesson, and I don't really remember which lesson that was, which involved similar triangles. How are the scale factors related? So I'll just tell you what to write here. Scale factors 5/6 and 6/5, that's a 6, are reciprocals. Remember, a reciprocal is when you take a fraction and you, in your guys' words, you flip it. How can the relationship of the scale factor between similar shapes help Lee? Well, the scale factor is the multiplier. What's the job of the multiplier? It is to multiply. Okay. Find the missing scale factor in the diagram at the right. That is, what could he multiply 100 by to solve for x? So if I go, look, if I go from the bigger triangle to the smaller triangle, I have to multiply by 2/5. Because remember, when you multiply by something smaller than 1, it gets smaller. So a bigger one going to smaller one, you have to multiply by something smaller than 1. And 2/5 is smaller than 1. However, if I want to go from the smaller triangle to the bigger triangle, I have to multiply by something larger than 1. So what is the reciprocal of 2/5? What is it? 5/2. Okay, so what are we going to say? So remember that box used to be empty, so I'm going to draw an empty box here, and we're going to say that equals 5/2. And the reason being, 5/2, that's a 5, is the reciprocal of 2/5. Use the new scale factor to find x. Okay. So if I did 100 times 5/2, remember that's my new multiplier, then I would get, what's 100 times 5? 500. 500 divided by 2 is 250. And I think it's miles. Okay. Does your answer agree with what we got in question 40? Yes. You can go back and look at question 40 if you don't believe me. All right. 42. Okay. As Linda and Lee were talking about the problem from question 39, their mother overheard and offered them another strategy. Here's how I would start solving the problem. She showed them the work at the right. Wait, is her mother driving the car? How is the mother teaching them math while she's driving the car? Okay, so look. We start with something to cover that up. We start with that. Okay? What is the opposite of multiplying by 2/5? Dividing by 2/5. So then they wrote it like this. They took that original one, like right there, and then they divided both sides by 2/5. Okay, and then one of the kids said, I see a giant 1. It was Lee. Where's the giant 1? Well, the giant 1's right here. Okay, so if I make that a giant 1, look, 2/5 divided by 2/5 equals 1. So, if we make that a 1, then I'm left with x equals 100, and I'm going to rewrite this, 100 divided by 2/5. So when you have 100 over 2/5, that's the same as saying 100 divided by 2/5. One way of making sense of 100 divided by 2/5 is to write it like that. Hey, that's what I just said. This could be read. How many 2/5 are in 100 wholes? With your team, find one way to explain how you would figure this out. Okay, so make sure I'm still on camera. 100 divided by 2/5. Now, I don't know if you recall, but we had a lesson a while back where we changed division of fractions into multiplication. So remember, the first number stayed the same. The division became multiplication, and then we did the reciprocal. What's the reciprocal of 2/5? It is 5 over 2. Okay, so then, again, what is 100 times 5? 500. Divided by 2 is 250 miles. I feel like we keep solving the same problem over and over again. All right. So Lee began to wonder how his diagram could help him solve his mother's equation. He showed his work below. So there's Lee's original. Right there. The 2/5 x equals 100. So then he knows he had to multiply both sides by 5 over 2. And when I multiply by both sides by 5 over 2, watch what happens. The 5's cross out because it's a giant 1, and the 2's cross out because that's a giant 1. So what am I left with on the left-hand side? Just x. Let's see what he's saying. How does Lee's work relate to the similar triangle diagram? What is 5 over 2 times 2 over 5x equal to? Oh, there's a lot of lines here. Okay, so 2/5 is the multiplier. To go from x to 100. That's using Lee's lie diagram from up there. 5 over 2 is the multiplier. Can I make it fit? Can you see that? Yes. Is the multiplier to go from 100 to x, because we're going the other way. 2/5 and 5 over 2 are reciprocals. So 5 over 2 times 2/5 x will just give me 1x, or you could just say x. Okay. Letter B, part B. Finish Lee's work to solve for x. Okay. So, we have 5 halves times 2/5 x equals 100 times 5 halves. Okay, so above we went like this. Remember, there's a giant 1 and there's a giant 1. So I'm just left with x. And then over here, what's 100 times 5 is 500 divided by 2. So then x will give me 250 miles. Okay. Hold that. Hey, I think this is the first in class we have with a staple. I'm gonna take a drink because my throat hurts. Did I just reach in front of the camera? Okay. Okay. Okay, last page, kids. Linda and Lee wondered how these new equation solving strategies would work with different equations. They made up more equations to try to solve. Copy the equations below on your paper. Oh, you don't have to, they're right there. And solve each equation by using one of the strategies from this lesson. Okay. How did you decide which strategy to use? Alright, well, we need the coefficient in front of the x to be 1. So, what's the reciprocal of 9 over 2? What is it? It's 2/9. So I'm going to rewrite this like this. You know what? I'm going to rewrite the problem. And I'm going to put parentheses around my original problem. Okay, so then I'm going to multiply both sides by the reciprocal, which is 2/9. Okay. And if it helps, I'm going to put a 1 underneath the 27. So look, giant 1, giant 1. So that's an x. What's 27 times 2? 54. What's 1 times 9? 9. How many times will 9 go into 54? 6. Ta-da! Alright, next. Oh, look it. My variable is on, it's on the right. I don't like that. So I'm going to rewrite it like this. 2/7x equals 12. I'm going to put a 1 under the 12. What's the reciprocal of 2/7? 7 over 2. Put a dot over there. Alright. So look, giant 1. I just have x. What's 12 times 7? What is 12 times 7? 84. 1 times 2 is 2. How many times will 2 go into 84? Lovely. 42. Circle. Okay. C has a negative sign. That shouldn't be a big deal. Copy it. 3/4 x, parentheses around my original, equals 21, parentheses, put a 1 under it. Okay, so what's the reciprocal of negative 3/4 x? It's negative 4/3 x. Okay, giant 1, x equals, what's 21 times negative 4? Negative 84. 1 times 3 is 3. How many I know it's going to be negative. How many times will 3 go into 84? 3 into 84. 3 times 2, that's 6. 24. 3 into 24 is 8. So this is negative 28. Dun-dun. I was a little worried that this one had a staple in it, but that took us less than 20 minutes. Alright. So, your homework tonight is 7-45 to 7-50. See you next time.